Welcome to lecture 18 of the course CS213 Object Oriented Programming of the Cohort University of Science and Technology. In this lecture we will discuss static and dynamic binding. We will talk about static and dynamic binding and casting. The relevant reading material for this lecture can be found in chapter 10 of the book Java How to Program Early Objects version Detail and Detail. Then there are some relevant tutorials that can be found, for example, on creating and using packages. We have also discussed this in previous lectures. Controlling access to members of a class. We have talked about this in access modifiers. Overriding and hiding methods and hiding fields might be discussed in this lecture as well. So if you have more than one method of the same name, for example when we are using method overriding, or two variables of same name in the same class hierarchy, for example if you have two variables of exactly the same name in the classes they are related by inheritance, it gets tricky to find out which one is used during runtime as a result of their reference in code. So for example we have we are using when we are using method overriding, and we saw this in polymorphism that the nature of the calling method changes based on the calling object. This problem is resolved using static and dynamic binding in Java. We will see in detail with the help of some examples that when do we know in advance that which method will be called or which variable will be accessed, and which methods and variables are we going to access using dynamic binding. Binding is the process used to link which method or variable to be called as a result of the reference in code. Most of the references is resolved during compile time. So for example, in the most of the cases, in majority of the cases, we will know in advance when we are compiling the program that which method would be called or which variable will be used. But there are situations where some references which depends upon object and polymorphism in Java is resolved during runtime when actual object is available, where for example we won't know until we run the program that which method will be called or which variable will be used. But we can look at some concepts examples where we can understand and know in advance which method would be called using dynamic binding. When a method call is resolved at compile time, it is known as static binding. So for example, when we know in advance which method would be called or which variable will be used, that is static binding. We know at the compile time, or we know in advance that this is exactly the method that will be called or run, or the code will be executed for that method or variable right at the start of the program. While if we invoke a method is and the method is the invocation is resolved at runtime, that is known as dynamic binding or late binding. So in dynamic binding, we do not know until we run the program that which method is going to be called or executed. Private, final, and static methods and variables use static binding and resolved by compiler because compiler knows that they can't be overridden, and only possible methods are those which are defined inside a class whose reference variable is used to call this method. So if we declare a method as private or final or static, or variables that are private or final or static, then we understand that we cannot override those methods or variables, and those variables and methods use static binding, and those methods and variables or those methods will only be possibly called by the exact classes where they have been declared by the objects of the exact classes where they have been declared. So we have no issues regarding the binding of the methods and variables when we declare them as private, final and static. Those variables and those methods will only be accessed by the objects of those classes where they have been defined. Static binding uses type information for binding while dynamic binding uses object to resolve binding. Static binding, for example, variables use static binding. Variables are resolved using static binding, which makes their execution fast because no time is wasted to find correct method during runtime. So when we declare variables and they are usually declared as private, they use static binding, and when we use static binding, we do not need to wait for the type of the variable or the type of the method or the output of the method. For execution or running the program, we know in advance what would the type of that variable will be. Private, final and static method, that as we already said that these use static binding. So when we declare a method as private, final or static, we understand that these cannot be overridden, and when we cannot override a method, then there is no confusion about which method will be called by the object of the class where that method has been declared. Overloaded methods are when there is we use the same name of the methods, but the number of parameters within that method are different. Those are resolved using static binding. So when we use method overloading, then there is no confusion about which method will be called, because when the number of parameters is different, then that becomes a different method. When we call that method, we pass exactly the same number of parameters as are being expected by the method declaration. Then based on the number of parameters, we know exactly which method will be called. So that is using static binding. Dynamic binding, overridden methods are resolved using dynamic binding at runtime. When we override methods, for example, a method has been defined in a superclass, then we have subclasses of that superclass implementing the same method, and overridden methods are when the signatures of the methods are the same, and by the signature we mean the name of the method and the number of parameters inside that method are the same. Then we are using method overriding, and that is resolved using dynamic binding. So the issue of dynamic binding arises when we are using method overriding. Java is type-safe language, and we compile time checks are carried out to determine whether variable usage is valid. So when we declare a variable in Java, we declare that variable with a certain data type. Java requires us, when we are assigning a value to that variable, that if the value of the variable matches the type of the data type that we have declared the variable with. Every variable name is bounded both to a static type at compile time by means of a data declaration. For example, when we declare an object or variable with the type of that object, for example, we are using a user defined data type over here, then this variable is bounded to this class or the data type that we have declared the object with. And we can also initialize this object, that is optional, to maybe some class as a reference to a class or to a null value. But now this is statically bound to the type of the object that we have declared this object with. The type imposes restrictions on how a variable can be used. The type restricts the classes of object to which the variable can refer and the message that can be sent using the variable. So now we can use this object. For example, the type restricts the classes of object to which the variable can refer. In simple terms, if we have declared this object as an object of this class or as a variable of this class, the cup class, then this object is bound to maybe access the variables in this class only and call the methods from this class, or if it is not this class has no subclass or superclass. This might be different from some languages like Python, where when we declare an object and we initialize the object with one value, we can change the value of that variable at runtime. For example, we can assign a different value to exact same variable x, which has been initialized to an integer value, and now we are assigning a string value to the same variable x in Java, but we cannot do this in Java. For example, in Java, when we have declared a variable as integer, it can only take an integer value. If we try to assign maybe a different value, of a different data type to this variable, in Python it is totally allowed, but in Java we cannot do this, because once we declare a variable with a certain data type, that variable is statically bounded to that data type now, and the usage of that variable is restricted only to the operations that is allowed by that data type. Static type restrictions. A reference variable of static type T. For example, if we declare an object of type T or a class type T, can refer to an instance of class T. We understand that. For example, if we declare a variable of type T and T is a class, it's a user defined data type maybe, or it can be a system defined data type, then it can refer to an instance of class type T, or to an instance of any of T's subclasses. And we have seen this in our previous lectures as well, that an object of the superclass is an object of the subclass. There is a relationship between these classes. The is a relationship applies only up the hierarchy. We understand that when we have a class cup, then coffee cup is a cup, tea cup is a cup. If you remember, we discussed this example in our polymorphism lecture. Coffee mug is a coffee cup, that is in turn a cup. Espresso cup is a coffee cup, that is in turn a cup. So the is a relationship applies only up the hierarchy. We cannot say that a cup is a tea cup. Every cup is not a tea cup. So we can only say that a teacup is a cup. The relationship does not apply down the hierarchy. And we need to take care of this when we declare objects of these classes. So for example, cup C can be declared an object of the subclass espresso cup, that is at the bottom of the hierarchy. We can declare this with the reference of the superclass, that is the supermost class cup C. Coffee cup C1, for example, coffee cup is the superclass of the espresso club, so that is totally valid. We can use the reference of the superclass, that is coffee cup in this case, to declare an object of the subclass, that is the espresso cup in this case. Espresso cup C2 here can only refer to its own object. It cannot be used as a reference for any objects of these superclasses, because a superclass is a subclass, but a subclass is not a superclass. So this is a valid declaration over here. Cup C3 For example, an object C3, the object name is C3 of the cup class, and this is a valid declaration. We can use the superclass reference to declare an object of the subclass, that is in this case the coffee mug. Coffee cup C4. So coffee cup again is a superclass of the coffee mug, and we understand that we can use the superclass reference to declare an object of the subclass. Coffee mug can only be used as according to our hierarchy to declare a variable of it, the coffee mug class only. Cup C6. So as we can see that since cup is the super class of all these subclasses, it can be used as a reference for the objects of all of these subclasses. So we can declare any of the objects of these subclasses using a reference of the superclass. All of these declarations are valid. But a superclass object cannot be treated as a subclass object because a superclass object is not an object of any of its subclasses. The reverse declaration will not be true. Even if you try this, you will get a compilation error. And the reason for that is, or the reason for that can be, subclass can have additional subclass only members. For example, if you inherited a class with some methods and then you add some more methods into the subclass, and those methods that are only in the subclass should not be able to be called by an object of the superclass. Therefore, assigning a superclass reference to a subclass variable is not allowed. That is why the reverse hierarchy is not allowed. So for example, a person P is used to declare an object of the person class. We cannot assign that object of the superclass to an object of the subclass. If we try to do this, and we need to remember this point, that if we try to do this, we will get a compilation error because these are incompatible. We talked about the compatibility of objects in detail when we were discussing the instance of operator. So we can see that if we try to assign an object of the superclass to an object of the subclass, we will get a compilation error. Static type restrictions, we'll talk more about restrictions, messages of, for example, method calls. Through a reference variable of static type T, the set of messages that can be sent using that variable are the methods defined by class T and its superclasses. So if you want to see what methods we can call through an object that has been declared with the static type T, for example, we discuss an example in our polymorphism lecture. We have a person class with certain methods like getName and cookDinner. Then we have a housechef class that is derived from the person class with some of its own methods. So the getName and the cookDinner method are inherited from the superclass, and the housechef has now the clean kitchen method of its own. So when we declare an object of the person class, for example, p.getName, p.cookDinner, these are valid. So we can call the superclass methods with the object p, and when we have an object of the subclass, like for example house chef, then we can call all the methods of the subclass with the object of the subclass. But if we try to call the subclass method with the object of the superclass, that will not be allowed by the compiler, and we will get a compile time error for this method call. So even though we have assigned an object of the subclass to the object of the superclass, we are still not able to call a method that has been declared in that subclass. That is why we are not allowed to assign objects of the superclass to objects of our subclasses, because the object of the superclass will not be able to access some of the methods that have been exclusively declared in our subclasses.